So today we are going to have a quick recap on expanding brackets that will end up in quadratic, and then we'll move on to factorization, but we're going to introduce the Algebra Tiles app, just in case any of you feel that might help you to work out a few kinks or misunderstandings in what's going on. Okay, so when we look at our quadratic expansion of brackets, you probably know this already, so we're looking at utilizing our FOIL method. So FOIL is firsts, so we've got x multiplied by x is x squared, outsides 1x, insides minus 12x, and then our lasts, which would make minus 12. Now there's one thing to add at this stage, is that the sign that we can use in between is this side, and that, as I'm sure you're aware, means it's an identity, and an identity would be true for all values of x. Okay. So this and this are just different forms. Now, obviously, this can be simplified to x squared subtract 11x subtract 12, right? But this symbol that I've just mentioned at the moment means it's an identity. So it means it doesn't matter what value of x you put in, you will always get the same result. So when we use an equal sign, that tends to mean there are a limited number of values that they are equivalent to. So something like x squared minus 11x minus 12 equals 2x plus 3. That's only going to be true potentially for like 1 or 2 values maximum, maybe even no values. Okay, so that's the difference between saying an identity and having an equation. All right. So, as I said, I want to have a look at using this algebra tiles thing. So let's have a look at one like x plus 2, x subtract 6. Now, I know you know how to do this, but let's have a look at this website. So I asked you to open up the algebra tiles yesterday. I gave you the link. So when we open it, we've got some options. Now we're going to want the ones with x squareds, right? You can click on change colors if you like, but we tend to have the reds meaning negative. So you can change the colors afterwards, but we're going to use this. And what we do is we set it out and we can use it to help us understand what's actually happening when we're multiplying. You might think it's a bit childish at this stage, but it can be quite useful. So for instance, if I want to do the question that we're talking about, which is x plus 2 and x minus 6. I'm going to represent that. So I'm going to put x, and then I'm going to have 2 units. I can make it slightly bigger if I want, just to fill my squares. The value of it doesn't matter so much, but just so it looks nice and fills my squares. So that's my x plus 2, and then I'm going to put my x subtract 6. I'm going to rotate it and put it on this side. And actually here I can make it negative. So this is x subtract 6 is 5, and then I can paste. So x subtract 6. Now we do our multiplication like you've done with multiplication grids before. So x multiplied by x would give me x squared. So I've still got my multiply by 5. So let's just go through and delete the ones I don't want. And then x multiplied by 1 would be an x. Fill the gap. Another one. And then underneath, x multiplied by negative 1, well, that's going to give me a negative x. I can fill them in for each one. And then I've got negative ones multiplied by positive ones will give me negative ones. Fill them in. You'll get used to using it. Okay. So what I can do now is I can move these out of the way because they're the question. These are the brackets. So what I'm left with is the expansion, and any positives and negatives will cancel each other out. So I can take positive, I think it will cancel out like that. And then what I'm left with would be my simplified result. So I'd be left with x squared, subtract 4x, minus 12. Okay? So just to confirm, so we did it like this before. So x squared, subtract 6x, plus 2x, subtract 12 gives me x squared, subtract 4x, subtract 12. So there is our identity. That and that mean the same thing. Okay? Okay, so moving on to factorization, because we can do that expansion. You've done it before. Let's have a look. So I'm now kind of looking at practice 2 on page 293. So we're going to have a look at factorizing something simple like x squared plus 7x plus 12. Okay, so we're going to find the identity but in factorized form. So again, I'm going to use the algebra tiles. You might, as an individual, decide you don't want to in the future, but it's worth having a look just in case it helps any of you understand. So we kind of know from our expanding the kind of the opposite way. So let's have a look what we can do with our algebra tiles. So what I've done is I've already set it up as x squared. There's 6 x's there, so I need another one. So there's my 7 x's, and there's 12 ones there. Now, what we can look at from our previous one, you'll notice that the result ended up as a rectangle. Now we cancelled some out, but we can still see the result was a rectangle based on what was down the side. So what we can try and do to figure out what the two brackets will be is set these up in a rectangle. So I'm going to start by putting my x squared in this top left-hand corner where it was. These will always be in the right-hand corner. So we kind of think the units, how can they be laid out so that we can make them into a rectangle? So if I look at something like that, there are obviously ways to do it, different ways to do it, but I've got a nice rectangle there. I can see that the whole thing would fit nicely. So then we can try and put my x values in, okay, to complete my rectangle. Right, so there is my rectangle. So they fit nicely, there's no spaces. If there were positives and negatives, you could then fill in any gaps using a positive and negative. We'll go through one like that in a minute. So once we've got our rectangle, we can then say, right, how do I get x squared? Switch off the 10. Well, x squared is made by doing x multiplied by x. So they would be your first two things in the brackets. Then x multiplied by what gives me 4 x's. So I'm going to have my 4 units. And then down here, x multiplied by what gives me 3 positive x's. So I'm going to have 3 of these. Okay. And then this time I'm going to select and take out the question, and they are my brackets. So I would have x plus 4 and x plus 3. So if we look at the question, this identity would then be x plus 4 and x plus 3. Now, if we look at it the way we've done it before, we would then see the 4 multiplied by the 3. So that would be our lasts, make the positive 12, and the 4 add the 3, make the positive 7. So that's how we may well have thought about it in the past, and say feel free to carry on, but if there was any kind of issues, then you can look at it that way. Okay, so another one I want to have a look at. So this would be E on this practice 2. So this was A. So again, let's go through this with our algebra tiles. Now, if we were going to do it before, we would try and find two numbers that multiply to make negative 18. They add together to make negative 7. So if you've got full understanding, carry on. But let's have a look at our algebra tiles. So I've already got these set up. Now, again, what we need to do, we've got our x squared, and we need to try and arrange my units into a rectangle at the bottom corner. So now you can see why it's those two numbers multiplied together makes this number, because it has to make a rectangle. So a rectangle would be length multiplied by width. So we've got 18 negatives. So how do we split the 18? So there are options. So I could do 6 lots of 3. Okay. I could do 2 lots of 9. So let's just have a look. Let's try 6 lots of 3 and see whether there's any problem with that or whether that's going to work. All right, so 6 lots of 3. But then what I've got to do is I've got to try and fit in my x values. Now, here's the problem. I've got some spaces. Now, spaces might not be an issue if I can fill in one negative with a positive, okay? And the reason for that is if I have a negative and I have a positive, they will not change the value because they cancel each other out. So we can have an x and a negative x, and I can add that into my, even though they weren't in my initial factorized form. So well, let's see what happens if I do that. So if I put that in there and I put this one in there, okay, well, what would be the problem? Well, because if I was going to factorize, I would have, this would be x subtract 3, but then I've got subtractions and positives, which might be absolutely fine, okay? But let's have a look at what would happen if I try. So how do I make x squared, positive x squared? Well, I could have x multiplied by x, okay? Then how do I make my negative x's? Well, I need negative 1. Okay, so that would give me my x multiplied by negative 1 would give me my negative x. But then negative 1 multiplied by something needs to give me negative 1. So that would have to be a 1. Now, this is where we then come up with our problem, because 1 multiplied by x does not give me the negative x. So this is not going to work. Okay, so we need to rethink it. So there's probably another option. So what if we made these negatives, for instance? There's negative x multiplied by negative x does give me positive x squared. Then negative x multiplied by positive 1 would give me negative x. Negative 1, well, that would then be negative 1. But then negative x multiplied by negative 1 would not give me negative x, it would mean positive x. So we're kind of saying at the moment that this is not really working for me. So going back to the beginning, let's have a look at a different way of doing it. So we tried our 6 lots of 3. Well, obviously another way to do it would be 9 lots of 2. So I've got my 18 in 2 lots of 9. Now I'm going to spread my x's out to try and complete my rectangle. Now what we thought about last time was actually we need to keep the same sign on one side. So I'm actually going to put all my negative x's down here. Now what's nice about this is I've now got 2 spaces, 2 spaces. So I can then fill them with this positive negative combination. So these will amount to 0, because as I said, they will cancel each other out if I do that. But what I can now do is complete my negative line, and then these two can go here. And I have a nice rectangle, and I have consistent positives and negatives on row and column. Right. So now we can look at, can I create my brackets? So now let's try with x multiplied by x to make my x squared. So now I've got x multiplied by what gives me x? Well, that's going to be 1 and 1. Now x multiplied by what gives me negative x? Well, that's going to be negative x. So I can fill that in. Give me enough. Okay, so I've filled in my rectangle on the outside. So let's remove this. Okay. And we see our brackets. So this would be x plus 2 and x subtract 6, 9, which for those of you that were doing it, okay, before, so x plus 2, x subtract 9. Okay, so you can then see 2 multiplied by negative 9 is negative 18. Positive 2, add negative 9, makes negative 7x. Okay, so like I say, if you don't feel the need to use the algebra tiles, that's fine. But for those of you that might want to make it work, you can. So one final one for us to go through. Well, what happens when we have more than one x squared, or a squared in this case? We can replace the x and the a. So I've set my tiles up in this way, put them out, and we do the same thing. We try and make our rectangle just like we did before, and I'm sure you can then see how my factorized form. So I would have 3x's plus 3 and 1x plus 1, and those would be my brackets. Okay, well, I'll let you have a play, and we'll have another talk about it next time. Maybe not using algebra tiles, but if it's something that has helped, then it's something that might help you understanding, and then you can move on from it later on.